So here's the velocity diagram with trench and lay pipe added as we're discussing. Now let's talk about how we got here again to clarify. So as we said, survey and layout is already here, and trench is the slower production rate, and lay pipe is the faster production rate. And we had this issue of when does lay pipe start such that it never overcomes trench. And so if we didn't think about this, we would just be like, okay, well, trench starts one day after clear grub. Well, let's do lay pipe 2 days after. Well, you could see the line has a slope approximately like my cursor and would overtake trench right here. Okay, well, what 4 or 5 more days, somewhere in this range. Okay, well, if we continue the line, well, they would get overtaken right here. Well, the faster way, as like it was articulated in the previous slides, was to look at the finish, then work backwards to figure out when lay pipe starts to forecast these activities. So first, trench is easy. Let's just add trench. We knew trench had a production rate of 25 days. We knew it wanted to start one day after clear grub. This was decided by the management team. One day after clear grub, start trench. Trench has 25 days. It's starting on the third day, so it should finish on the 28th day up here. So connect that line. That's good. Now, when does lay pipe start? That's the question. How did I get this number? Well, we know that lay pipe has a production rate of 17 days. And we know that we want, for safety reasons, to have lay pipe finish 2 days, give it a time buffer of 2 days after trench. So that gives us the finish date of the 30th. Okay, so then how do I figure out when that starts? Well, 30 minus the production rate of 17, if you go back in the slides and see, gives us the 13th, which is down here. So that tells us when it should start, such that it finishes 2 days after lay pipe. So the previous slides were articulating this process of starting the activities, or looking at the activities, finish date to figure out its start date. So that's how we figured out lay pipe, such that the line doesn't ever overcome trench. Okay, so then the last activity to include is backfill, just to cover the linear hole with dirt, cover the pipe with dirt. That has a duration of 20 days. It has a lower productivity rate than its predecessor, so the slope of the line will be less steep. The management team desires to start backfill 2 days after, so that's a 2-day time buffer of lay pipe. It takes 20 days, it's starting 2 days after, so then we'll just add that to the chart, which will also show the finished product momentarily. We've already added them to the chart. The next thing is to look for any conflicts or time buffers. So let's discuss those briefly. So the benefit of this type of schedule is to examine and plan out your schedule beforehand and look at a time and space buffer. So a time buffer is what we've been using throughout our example. It's the amount of time horizontally between activities at any given point. This relates to the physical activities on site at the job and the physical distance between the lines on the chart relative to the scale of the chart. A space buffer is the amount of space vertically between the activities at any given point, and it's also the amount of space in between the lines on the chart relative to the scale of the chart. However, one is relating to time and one is relating to space. So the actual distance and this was actually the time between each other. So then the management team, like in the example you saw, like the management team was coming up with these based off of safety reasons and based off of quality reasons and based off of what they've done before. So an example we'll do for class, I'll give you these and we'll work off of those. So here is the time examples of time and space buffer, and here's also the last activity added to backfill. We wanted it to do it 2 days after lay pipe. It takes so then therefore it will finish on the 35th because it takes 20 days to for duration to finish, and so that concludes all of all the activities added to the schedule. So let's look at the space and time buffers again. The space buffer, like I said, is the physical distance between the lines on the chart, and the time buffer is the space buffer is the physical distance between the lines on the chart vertically. Time buffer is the physical distance on the lines in the chart horizontally. The easiest way to memorize these and figure these out is duration is on the x-axis and it's in time, units of time, days. So the time buffer would have to correspond to the horizontal distance. So same thing with the space buffer, that refers to distance in something in feet, and that's on the vertical axis. So that should refer to a space buffer, the vertical distance between the two lines. So then there could be questions of what is the minimum space buffer, vertical distance between lay pipe and backfill? Well, what is their minimum closeness to each other vertically? Well, that looks to be about 3 squares vertically, which is about 800 feet, somewhere in there, 700 feet. These are in 1000s by 5, so every 200, so 600. So 200, 400, 600 is the actual answer. And then the minimum time buffer between trench and lay pipe, well, that was decided previously in the example, so that's 2 days time. What was the maximum time buffer between lay pipe and backfill? Well, the maximum distance between each other up here is the 5 days. So in addition to the time and space buffers, you can actually add bars onto this type of schedule, just like a bar chart, and mostly be to use for like notes. So you can add this note down here, owner in town for the duration of these next 4 days, or equipment arriving and have like a bar somewhere else, or material arriving, things like that, or break coming up for a holiday. So you can just add that to the chart. So that's it. We've gone through all the activities, or all of the steps into creating these. The last was to look for these buffers. Generally through the process, we'll kind of anticipate these, but if you go back and look at this, you could maybe see you're done, but you could see like, okay, well actually maybe we do want an additional time buffer between lay pipe and backfill, or maybe the space buffer between 2 activities gets too close on day 5. Maybe we should refine that and move it and give it an additional day, something like that. Okay, so in a separate video, I'm going to do another example of how to create these linear line of balance. So look for that video also. But before, in this video, I'm going to discuss these case studies. Like I said at the beginning of the previous video, is that the textbook has a whole bunch of administrative issues, and I decided to take a different route and describe things that have happened in real life that was due to poor project administration. The primary one is the Hyatt Regency walkway collapse. It's pretty famous. It happened in 1981. It's probably talked about in every single civil engineering program in the world, probably most construction programs. And so if you haven't heard it, then you're going to hear it in this class. So it happened in Kansas City, Missouri, like I said, in 1981. The major issue was just due to negligence. So about 114 people died and over 200 people were injured, and there was numerous lawsuits, and it was all due to poor project administration, things that we've discussed in this class up to this point that were administered poorly. So here's a little rendering of the plan. This is a nice hotel. You've probably been in one of these hotels before. And this is a suspended walkway in the interior where you would access your rooms. Here there would be the doors and doors up here, and so these walkways were suspended, and the original plan was to have these bars that would suspend the 2 walkways together. The plan was to have the suspension rod go through these 2 C channels, and the constructor realized, well, that's kind of difficult to thread the bolt all the way up through the rod, which is, the rod's upward and like 10 to 20 feet long, and it would be easier if we just splice the rod and then we thread the bolt on each side, or the nut here on each side along the threads. That would just be a lot easier to construct. Sent this change to the engineer, and the engineer did not review it for its structural capacity, and just stamped it and sent it along and told the constructor it is okay and acceptable to do that. Well, this change, since it was not analyzed, resulted in the failure of that walkway. I think there was a big grand opening, and there was a lot of people dancing on there, and so it was had a lot of live load, and ultimately failed. You could see in the wreckage that these suspension rods just pulled directly through that C channel, two double C channels. So ultimately, what happened? A summary: engineer designed the continuous rod support. The contractor requested the double rod support. Then the engineer approved but did not reanalyze the revised design. So then the fourth floor box beam carried the load, ultimately carrying the load of all of the floors above it. And then ultimately there was a collapse. Then the two engineers that designed this, just approved it and did not reevaluate this, then had their license revoked because of poor project administration. They didn't go through the proper steps of reanalyzing that and confirming that that is okay. And so I highly recommend you go to the Wikipedia page, read up more on this. It goes into the details of what actually happened, more into detail about the structural analysis, and talks about what those two engineers are doing to date. The last time I read it, I remember that they're not practicing engineers anymore, but they were going around and giving discussions about poor project administration and what lessons learned from what they did, such that they continue to inspire engineers to go through the actual protocol and constructors to go through proper project administration. Now then, there's a couple other examples I found around the internet of just interesting things that I like to just bring up due to poor project administration. There's this building, which when I looked it up and read about it, there was people actually occupying this building at the time, so it possibly looks like that was an existing walkway up here, which currently goes to nowhere. So it's obviously a huge safety issue because someone could just walk out this door, or open out this window and go to this walkway, and there's nothing there. Here's the other side view of this house. Again, there might have been a balcony up here, which is also very interesting. There's probably maybe supports right here for that balcony. Another interesting thing is these doors weirdly don't match each other. I thought it was interesting that the third floor was boarded up, but the second floor was not. So I found that kind of funny. This is also kind of funny. This was designed this way, but no one actually reviewed it to see that two people aren't actually going to probably use those at the same time. So I found that quite hilarious. This is kind of like an MC Escher painting. Notice that if you didn't realize, the stairway has no landing to turn around. You would walk up the stairs and immediately hit your head somewhere up here. You would have to parkour around these stairs to walk up. So they just constructed it based off of the plans. There was no review. No one asked questions of okay, is this how we're supposed to do this? This one's not quite as obvious. This one's pretty hilarious to me, but it's not quite as obvious. So what is obvious is there was a hole, just a general hole drilled into the concrete. But notice it's kind of clouded shape. Someone used a core drill to cut this out. Well, what also is clouded shape is revisions on construction drawings or blueprints, if you will. So if there's ever any revisions, you highlight that revision with a cloud bubble. So if there's dimensional revisions, you cloud that in, add the new one there. Someone thought that they should actually literally drill a hole in the shape of that cloud on the drawings, and so I thought that was quite hilarious. So in general, these were just some funny pictures that I found on the internet. They're all due to project administration, no one asking questions, no one going through the proper routes that we've discussed throughout this class. I just thought it was more fun to discuss funny issues and lessons learned rather than traditional lecture on this. So there will be a homework, create a linear line of balance homework. I will email that out, or it'll be on Tracks. I'll email with the due date for that specific homework. It will also be on the assignment.